All right. So like Courtney said, yes, my name is Mike Hartington. You can find me, M. Hartington, basically everywhere online. And this talk's called Rise Above the Framework. Or, who's ever seen the movie Dr. Strangelove? No? A few people? OK. So it's also called How I Learned to Love Web Standards and Stop Worrying. Because I really believe that this is a more accurate description of what we're going to be talking about and trying to understand what it's like to build web apps today. So this is a photo of me and my friend Adam. He is the one with the glasses, and I'm the one with the scotch. He's a designer based in New York City. We both went to school together, actually, for art and graphic design. My graphic design career didn't work out so well, but his did. So he's a very successful designer in New York City. And he spends all his days working on great design, great print advertising, and great digital ads. But he came to me with a question. He's like, I want to build a web app. I want to build something for the web today, and I want to build something using the greatest technologies, the greatest techniques that people are using in their development. I want to learn all this stuff. So I was so excited. I was like, oh my God, we're going to build something? OK, cool. So first we got to figure out what kind of framework are we going to use. Are we going to use Angular? Are we going to use Vue.js? Are we going to use React? Are we going to use Preact? I know they sound the same, but they're kind of different, but they're also kind of the same. OK, well, that's cool. Now we got to figure out, what about our CSS? Are we going to use raw CSS? Because no one really writes CSS anymore. They all use CSS and JavaScript. That's what everyone does these days. What about Sass? I hear Sass is a pretty cool tool. We also have things like Less and Stylus and PostCSS, whatever that is. We also have things like Webpack. We all heard about Webpack last talk. What about how great Webpack is? It's so fun to configure and just set up to get everything to work really well. And then config files. We always have to have a config file. So everything's a .config and, oh, Webpack config or Jest config. We all have these files that we have to take care of. And this is kind of the point where I lost him. It wasn't his fault. It was kind of the stuff that we all put ourselves through on a daily basis. So after this happened, I took a long amount of time to just think about, why did he decide that he wasn't going to build an app anymore? Why did this scare him away? I build with this stuff on a daily basis, and I'm sure many of you do as well. But I started to think, back when I started my career as a web developer, the front end was pretty easy, for lack of a better word. I just took some jQuery, backbone, maybe underscore, threw it in a web page, and I called it a day. I was done. But if I needed something more advanced, maybe I used AngularJS, Knockout. Ember was a thing for about a little bit for me. I tried it, then found Angular, and I was happy. But we kind of had this period of growth, or a renaissance, where we went from just doing simple JavaScript into the page we want to use to building everything in JavaScript. There was no more HTML. It was all JavaScript. And that kind of got really confusing and very complicated rather quickly. So now, to only add in that we are learning all these different frameworks and all these different approaches, we now have to figure out, OK, what about JSX? Decorators, template compilation, code splitting, lazy loading, all the various types of CSS processors, whether or not we're using CSS modules, CSS and JS, different build tools, Webpack, Parcel, Rollup, and again, the config files. Again, these are things that I grew up with as throughout my career, and I'm starting to realize that developers who are just getting into this field, they have to know so much in order to just build Hello World. So this is really frustrating. It's becoming very apparent that not everyone wants to do this kind of stuff. And so I've been going through this period where I was looking to what the web standards say, and trying to find out, do I abandon all my previous knowledge of frameworks, libraries, and just go use everything that's available on the web today? Or can I find this perfect balance point where I can start to pull in all these things from from the web standards and what they say that we can do on the web, and integrate that with my frameworks like Angular, React, Vue.js. So between that, I kind of broke it down into 3 different concepts: CSS, JavaScript, and components. If you really look, it could say HTML in there, so it would be the 3 building blocks of the web. But we'll go through each one of these. And the first part is CSS. So we're going to try to tackle CSS's 2 biggest issues, and that is global styles and dynamic values. So global styles. Everyone who ever takes a intro to programming or CS 101 or even does a couple tutorials online quickly learns that anything global is considered an anti-pattern. It's the same for JavaScript, same for Python, same for any language that you're using, but it's not the same for CSS. CSS, we are happy to take an entire library like Bootstrap, which has over 600 different classes, and just throw it in our page. And if it affects anything in our HTML, we're just like, OK, I have to deal with that, I guess. So whatever. So why should CSS be any different? With global styles, we also have to deal with the second problem that is kind of inherent with CSS, and that's the cascade. How many times have you taken a bit of CSS, written a new block, and then somewhere way down into your HTML, you're like, why is this style getting applied? I didn't want this. This wasn't expected. But because of the cascading nature of CSS, it is cascading style sheets. This is just a thing that we have to deal with. And then as you start to include all of these different libraries, maybe there are times when they are just targeting elements. Like, I want my button tag to look like a button. I don't want Bootstrap to come in and say, you were making a button, you should probably use this style. It's like, no. I want my button to look like Chrome tells me to look, what the button should look like. Don't touch anything, just kind of leave it alone. If you're trying to do resets and override whatever a library is saying, you often just are creating empty blocks that are just resetting rules. So kind of difficult, kind of a pain in the ass. Come on, clicker. It'd be really great if you would work. Cool. So the React community has kind of come together and agreed upon probably these two practices as the way to solve CSS in modern front end. And that's CSS and JavaScript and CSS modules. Now, while these are really great ideas and practices, they have a bunch of shortcomings. For example, CSS and JavaScript, you are often limited to what kind of CSS you can use. You have to relearn basic rules and to sometimes this can be a number or sometimes this can be a string. And why? Because that's what the author said so. CSS modules kind of brings us a little bit back to real CSS by allowing us to write CSS. But at the same time, we have to now include a build step to change the selectors. That way, it's something random that there are going to be no conflicting rules. And it's just, I don't want to set up a build step. That's just one of the things I don't ever want to do these days. So how can we fix this in CSS? And that's Shadow DOM. It's a really cool name for something that's not that cool. Shadow DOM is simply a way to say, I have this part of a component, remove it from the global scope. Basically, take this bit of DOM, create its own DOM. Sounds a little confusing, but it's actually simple way. It's actually pretty easy to look at. Because the template of my Shadow DOM is now scoped, so is my CSS. So if I have any rules, if I have any styles that are embedded inside of the Shadow DOM, any selectors that are in there are only going to be affected for that part of my component. So global rules, completely gone. We don't need to worry about it. Well, now if all of our rules aren't global, why do we need classes? Why don't we just use element selectors. That's pretty cool. Why don't we start simplifying all the styles that we're authoring? So we get a benefit of having all of our styles encapsulated and scoped, and having all the CSS that we actually have to write be much simpler and easier to reason about. And if you follow that link down in the slides, it brings you to a Google article where you can find out all about Shadow DOM. But the kind of TLDR is we create a div element, and then on that div element we can call attach shadow, and then pass in an option to say, I want this to be open. So whenever someone queries for it, if there's any child content in there, they can affect it. They can modify it with JavaScript, or even somehow figure out how to do their own custom CSS. Now, once we have that shadow root created, we're going to set the inner HTML, or we could call append child if we want to, but inner HTML is so much easier. We can just use template strings. We can link to external CSS files. So if you're curious about, I have this kind of global CSS file that I want to include for some theming, or we could do inline style blocks and just inline that right inside of the template. From there, we can just add whatever DOM nodes we want, and it could be a deeply nested component, or it could just be another component with Shadow DOM. When we're done, if we really just want to do something simple, we can just append it to the body and call it a day. And definitely take a look at that bit.ly. It will go over all the basics of how to actually use this code. So all of our styles get encapsulated with Shadow DOM. We don't have to worry about global scope. What about the next problem of dynamic values? Well, that's pretty simple. We just add variables into it. We already got rid of global scope, so we add CSS variables, and we can start to affect how styles are written by having a variable syntax that works with or without Shadow DOM. Now, how many people build apps with different themes? Like you have administrator or a basic user. How many people build apps like that? A few people. One of the things that you have to do now to actually achieve that is end up creating two different CSS files. Here's my admin CSS file, and here's my basic user CSS file. CSS variables actually change this. By just creating this block called root, we can create a variable called appColorRed and set its value to red's hex code. From there, we can create another variable for the font family. We can set it to Helvetica. It could be whatever you want. But once we want to actually use these variables, we can say, here is my h1. I want its color to be whatever the value of this variable is. We can use the var function in CSS. Yes, CSS has functions. It's pretty cool. And we can just pass it in this variable name that we want to reference. And at runtime, it'll figure out what value we should use. We can take it a step further and actually use JavaScript to modify what this value is on an element-by-element basis. So even if we declare a variable at the root of our page, if we redefine that variable inside of a different selector, it'll use that value instead of the global one. Now, once we start using this JavaScript approach, we can start to do pretty cool things. Like we could create a range slider, which will change the value of a div by whatever value it is. We can go from 0 to 255, and we can make a div either be completely white to bright red, or create any kind of RGB slider. And there's a great example in here from Wes Boss, where he does the exact same thing inside of CodePen with just using CSS variables. So we have Shadow DOM, we have CSS variables. It's kind of fixes CSS, and it solves most of the problems that people often need, libraries or build tools. What about JavaScript? How are we going to fix JavaScript? A lot of people say JavaScript doesn't need fixing, but I would argue that we probably do want to fix at least these two big points, which is code that we're shipping and transpiling it, and tying ourselves too much to build tools. If Sean Larkin's in here, I'm so sorry. I'm not gonna make any jokes at Webpack, I promise. So, like I said, the old way when I was learning was if I wanted to include some kind of JavaScript into the page, I would just add a script tag. And I could always guarantee that I was writing ES5. There was no other kind of language. There hadn't been for years. ES5 is pretty well standardized. We can just use that. But then ES6 kind of started popping up, and it was renamed to ES 2015. And then a year later, we had ES 2016 and 2017 and 2018. And every year, there's a new version of JavaScript with new features, new capabilities that we're able to use in the browser. But not all browsers implement these features right away. So what do? Well, we create build tools. We have great things like Babel, which completely transform how we write our code today. We have TypeScript, which also offers the same features. And then we have tools like Rollup and Webpack, which allow us to integrate this into our setup. Now, a while back, we probably heard the term JavaScript fatigue. And I don't think it's an accurate description. I think really what we kind of felt was a build tool fatigue. Like, we were all just tired of configuring all these different tools and relying on everything to be compiled down and run into the browser. Well, it's not only affecting us as developers, it was also affecting all of our users. So for people who are using async await inside of using Babel or TypeScript, have you ever considered looking at the compiled code for async await? If you target ES5, you get automatically this 100-line function to replicate async await in an ES5 manner. And then if you start to write that and use everything async await, well, now we just have this really slow code that, sure, we're using async await, but it's super slow, and our users have to download this massive bit of code for our benefit. That feels kind of unnecessary. But there's a way we can work around this. Much like everything, the standards body kind of figured out that we should probably fix a lot of this stuff. So we have this thing called script type module. Now, I'm not going to talk about using ES modules in the browser today, because that is a very hot topic, and I am nowhere near smart enough to be able to talk about it in detail. But what I will use script type module for is its ability to detect features. So if you ship code using script type module, guess what? You automatically have support for things like async await. No transpilers, no compilers needed. We get to use class syntax. Arrow functions, something that we all kind of think is like, oh, arrow functions, that's so commonplace. Well, not really, and we get to use them inside of script type module. But we also get fetch, promises, all these different array methods, everything that we come to know and love about our modern, fancy JavaScript. We don't have to pay the cost for transpiling it down. But there's always that one person who goes, I work in enterprise. I have to support IE11. Or there's always, that's my only IE11 joke, I promise. There are always older browsers that we have to consider. What do we do about them? Script type no module, because of course there's got to be a no module version of this. So we have these two different ways of loading code, and if you have script type no module and script type module, if you are on an evergreen browser or on a browser that supports that syntax, it'll just load the script type module version. If you are on a browser that doesn't support script type module, it's going to load the no module version with some exceptions. I'm not going to get into what those are, but we can thank Apple for that. But essentially, we can just say, hey, I'm on an older browser. Give me the transpiled version of my code that's compatible with ES5, and I can get on my way. And this is where we can actually thank a framework for doing this. So the Vue.js team actually added this feature, which was inspired by Meteor. Yeah, that's a name I haven't heard in a while. But we have this feature where we can take all of this code, we can say, create an ES 2015 bundle, and then create a legacy bundle. Now we have code that will run in the browser with no transpilation. Everything's going to be minified. We won't have to worry about, oh, well, what's the cost going to be for using async await? Now, the Vue CLI actually has this in their beta release. And so far, they're the only one that I've seen that has shipped this. But I really hope that if you learn anything, try to pressure any of the frameworks that you use to offering this feature. So React and React scripts and Angular CLI, I would really like to see this feature get added. So components. This is something I've definitely been invested in for forever now, it feels like. But basically looking at how can we create components in a way that removes any lock-in to a particular technology. Because guess what? Frameworks and libraries tend to have breaking changes every now and then. So from components, we kind of have like a little history lesson where we were doing like traditional MVC kind of style of building out our web apps. And around this, we had this idea from AngularJS called directives. For anyone who hasn't written AngularJS, it's essentially a way to say, I have a custom tag, and here's its functionality that should be implemented on it. It might have some exported properties that users can pass data into. I'm probably wrong about this, but I like to think that this was the first kind of idea of a component in the browser, or in a framework. Then React came in and kind of changed the game, and it was like, nope, all components, all the time. MVC, that's stupid. We should be doing components all the way from the top root level of our app to a random modal that pops up to subscribe to our email list. So React was like, oh, this is so cool. We'll just create this class, and it's going to extend the built-in React component. We're going to call our render method, and it's just going to return some JSX. What's JSX? JavaScript representation of HTML, obviously. So we have this really nice kind of simple way of creating an app root component. Angular liked that idea, and they kind of did something similar where they have this at component decorator, where we can say, hey, here's the selector that we should attach to, and then here's the template. Again, it could be an external file or an inline string, but it's still HTML. From there, we can just say give it a class to attach, and we have a component. Vue does a similar thing where they say, hey, I have a component. Here is the selector, and then here's the template. Now, hopefully, between these three, you've kind of seen a similar pattern. We have a tag name, and then we have the actual functionality and implementation details that are associated with that tag. And while Angular, Vue, and React aren't the only frameworks, it kind of gets to the same point. We have a different framework, and with each one of these frameworks, we have a different API for authoring components. You want to use a React component inside of Angular? You can't. Want to use an Angular component inside of Vue? Can't do that. It doesn't work. Because of these APIs and because of how different they are, you get locked into that framework. And while some people are happy about that, imagine changing jobs or changing stacks. All that code that you had before, you have to now rewrite, and it's just not fun. So we can fix this by just looking at custom elements. Now, who's heard of custom elements? Who's using them? I really wish it was more people. So custom elements is like a nice way of saying web components. It's actually an aspect of the whole web components model where we can say, here is a tag name, and then here is the class implementation. So essentially, everything we're doing with React, Angular, and Vue, just built into the browser. So no framework needed. It's built into the browser, and it's part of the standards, which I think really goes to show you that if you have a web component and say something in the standard changes, it's not going to necessarily break. Because of the agreement standard bodies have said, it's like, we're not going to break the web. We'll have to figure out a way to change this behavior that is backwards compatible. So web components that can be written today, 10 years from now, they'll probably still work. Just like we can go to old websites that have a bunch of GIFs and animated blinking text, web components will still work. There we go. So we have this pretty simple syntax for it. We have a class, and instead of extending a arbitrary frameworks component, we are going to extend the base HTML component. So essentially a div. And here we're just going to initialize our base, and then we have this thing called connected callback. Now connected callback is our lifecycle hooks. So same way that we have ng on init in Angular, or in Vue we have mounted, and inside of React we have component did receive props, I believe. we can start to call functionality once this DOM node has been inserted into the DOM. So we'll call it this.init. It could be something called render. It's just a name. We'll call render or this.init, and we can set the inner HTML for our component to be hello world. So that's essentially all the component that we really need to use. But the important part is that if we want to tell the browser about this, we call custom_elements.define and pass it the tag name. Now, this tag names could be arbitrary, but the only thing that you really need to know is that the tag name should be hyphen separated. This is a way to avoid collision with built-ins that the browser has. So a lot of people will namespace their own components. For Ionic, we do ion as a prefix, but we have this really nice way of saying, here is the implementation, here's the definition, reference the implementation, and call it a day. So with custom elements, we get all the great things that you could expect to get from a framework. We have custom elements and custom attributes and properties that we can be set onto the component. We have shadow DOM if we really want to use it. Again, it's not a hard requirement, but you lose out on all the things like style encapsulation. We get lifecycle hooks. So anytime the component has been added to the DOM, a hook will get fired. Anytime a component has its attributes or properties have changed, we get a callback. And anytime we remove an element from the DOM, we have another lifecycle hook that we can attach to. Pretty nice. And then we could also use things like custom events. So Angular has this idea of output, where we can output event and pass data through that. Well, we can do the same thing with custom events. But if you're like me, I don't really like that syntax. I'm sure the functionality works, but I just don't want to write that. And if you were to try to go ahead and update any properties onto that element, it wouldn't actually re-render. You need to manually handle that yourself. So some very talented people have created this whole series of micro-libraries. I work on one called Stencil. It's pretty nice. Maybe you've heard of it. If not, come by our booth. But we have Stencil, which allows us to create some web components. Skate.js is also another one. If you're from the Polymer world, there's things like lit.html, lit.element, and lit.html by my good friend Kenneth over there. So all these kind of libraries, they give you the nice parts of a framework, but at a much smaller cost. Like an example stencil component can be less than a K, which is crazy. Now, the frameworks have kind of seen this happen, and they thought, this is a really good idea. We should probably get on board with this. So Angular has come up with the idea of Angular elements, where you can take an entire Angular component and compile it down to a web component that can be loaded in the browser without having to bootstrap Angular itself. Vue is also doing the same thing, where they set a target option, where you can compile a Vue component as a web component, and it will handle instantiating all of Vue and all of Vue's APIs. The thing to note is that with both of these options, you are eventually including the framework itself. So it's not ideal at the moment. For instance, an Angular element will still need to include a lot of Angular's APIs, like dependency injection, and how it creates DOM nodes. And the same thing with Vue. You're still including Vue into the code base, so these components can be a little bit large, but it's a great first step. We are now getting to the point where frameworks are like, yeah, we should probably use standards. Except for the one super popular one that is kind of, I don't know. React has not really said whether or not that they think web components are a good thing, or that they want to support it. And while you can use web components inside of React, there are a bunch of quirks that you have to be aware of. They're all really well documented, but if you go to customelementseverywhere.com, made by the lovely human being Rob Dotson, you will find a list of open issues on the React repository. Go ahead and +1 that, or go to the emoji reaction, because don't ever type +1 inside of an actual issue. But voice your opinion to these frameworks and let them know. It's like, hey, React, I really want to use custom elements and web components inside of my React app. So I talked about 3 things. I don't know. CSS, JavaScript, and components. We had the styling, we have our scripting, and we have our building blocks. So CSS, JavaScript, and HTML. Things that we typically relied on frameworks for a number of years now, well, standards have kind of caught up. We can start to author all of these components in a framework-agnostic way and know that they're not going to break 10, 15 years in the future. Whereas frameworks, we're not really certain if they're going to work in 6 months. That's kind of a disappointing thing. So what I would really encourage you all to think about is next time you go to a new app, or if you have an existing app that you are maintaining, think about, what can I do with web standards today? What can I do to replace a portion of my app with web components? What can I do to replace my CSS and JavaScript library with CSS variables and Shadow DOM? All of these standards are around to help you build better apps with less code. And as we've heard already from Sean Larkin, it's really about the amount of code that you are sending down to the browser. So if you are using a framework that includes megabytes of code just to create an element, you might want to reconsider it. So, thank you.